Yeah, exception handling is another key feature of any language where we handle exceptions. Error is a thing which is thrown by the runtime. Exception also happens in the runtime. Error which happens in the code itself, but exception happens with the functionality, and there is a functionality or your input output values, based on output values you will have exceptions. For exception handling we have a feature called try, catch and finally. Finally is not a mandatory thing, but try and catch are a mandatory thing. We are giving a set of lines inside the try. We try that code. If any exception happens, we handle that in the catch. And finally is the part which will run whatever may happen, whether the exception happens or not. For example, if the try block alone runs and the code runs without any exception smoothly, then also the try block catch finally block will run the try code first, then it will run the finally. Even if exception happens, then it will run the try block, then the catch block, then the finally will run. That's why it's named as finally. Whatever happens, finally this code will run. Real-time example we can use for is some of the unhandled code or some other things happening out of our scope, like showing any dialogues apart from after execution of our code, or those kind of things we can handle and close with the finally block. Here I have a few methods to explain. Here I deliberately make an exception. Finally clause also, you will see some more methods in the next class along with the string handling. See here I am giving a path. I am deliberately making an exception to happen in the try block. I am giving a path which is not available. Result drive is not there, so I am giving a invalid path. So it will tell I came. This will print I am from try block. This will print I am from catch, and it will display. This you have to use in whichever code you write, whatever code you write, you have to use try block. And in our real-time environment, we capture this code, and we, on some cases, we print it to the reports, and in some cases we write it to the logs. For that we use this, and this will be a practical need. You will have a practical implementation in all part of the codes. And another important thing is, if you are writing a real-time code, in that case you will have multiple levels of flow of code. For example, you are having a main page, and inside that particular functionality, for example, take the print call scenario. Print call main block, you will have the test methods, and you will call in turn call the page objects from that. Inside the page objects, it will call the particular functionality. For example, print call test page, then print call business object page, and then from there the business logic method. Like that the flow will go. If it fails in the last level, then wherever you are handling exception handling, at that place only you will be able to capture the error. Instead, if you write the try catch block for individual methods at the root level itself, you can narrow down the defect analysis, where the bug happened, where it stopped. That kind of analysis you can do at a narrowed down level if you use try catch block properly. Otherwise, you have to spend a lot of time finding where it broke on a bigger point of code, I am telling. For a smaller code you can easily find out. On a larger level of code, how you use try catch block plays a big role. Okay, here I am giving a invalid path, and it will till I am from the cache block, this error will throw, and finally it will also get shown. That is with exception. This method is without exception. It just prints I am from try block, I am from cache block, I am from finally. Here this won't get printed as exception didn't happen, cache block won't get called. And another thing is you can have n number of cache blocks. If you have a try block with a larger code and you assume some n number of exceptions can happen, like that file handling, invalid file, invalid path, file corrupted file, those kind of exceptions you want to handle, means you can have n number of cache blocks. But finally there will be only one finally. Here the same thing, this is not good. Okay, this I will show. This is what I have written so far. I will write a few more methods and show in the next thing, next session. So I am calling methods one by one. The first one I am printing I am from try block with exception. First method we are calling is with exception. So I am from cache block and could not find a part of the path is printed from the same cache block, and finally is getting printed. The second, you can ignore the third method. Second one, method without exception, try block is printing, then finally is printing. The cache block is not printing, as in there is no exception happening, the cache block is not called. Okay, you can ignore the third one. And another point I want to mention here is, see the exception cache blocks, how you handle is, you have to give the smaller level or sub level of exceptions on the top, and the exception should be the last one, as exception is a parent of all the individual exceptions. You have to give that as a last cache block. Is that clear? This is a very important point. Hello?
Okay.
Yeah. You have to give the exception. Yeah. If you give exception above this one, it will be a compile time issues. See, if you click this, a cache class already catches all exceptions. So this is a super exception which will be a parent of all the exceptions. So you have to give this at the bottom. This you practice well and you try to use whatever code you write. This we use extensively to do root cause analysis. This will be very helpful. All reporting and logging mechanism will be based on this one. I think this is enough for today.